Yeah, welcome everyone to the ECC webinar. My name is Calder Shigrin. I'm one of the co-chairs of the SMRA Early Career Committee. I'm joined also by Yun Guo, who is also on the meeting. I'm in the Minneapolis airport as it happens. Travel got very waylaid. But anyways, we're very excited to have you here to discuss some thoughts on kind of career trajectories from academia, industry, and clinical perspectives. So with that, I'll hand over to our moderators, Judith Jazor and Turun Naren, to start the webinar. Thank you.
So hi everyone. I'm Tarun, and my co-host Yudit is also um in the call. So we'll be having three speakers talk to us today. Dr. Anastasia Fotaki from King's College London, Dr. Gastao Cruz from University of Michigan, and Dr. Ning Jin from Siemens Healthineers. So now I'll hand it over to Judith.
Thank you, Taron. We are thrilled to welcome our speakers and every attendee at our webinar. And now each speaker will be present for 5 minutes, and the speakers can freely share their screen and use slides during their presentations. And in the meantime, we encourage the audience to ask questions via the chat. We will address these questions at the end of the webinar. So let's get started with the presentations. Our first speaker is Dr. Anastasia Fotaki from King's College London. Dr. Fotaki, please proceed with your presentation. Thank you.
Hello, everyone. Thank you very much for the invitation and for organizing this event. I have prepared, let me share it, a very short presentation on my background. I hope you can see my screen. Yes, so my name is Anastasia Fotaki. I'm a consultant in pediatric cardiology and congenital imaging in congenital heart disease. From a clinical perspective, I work primarily at Royal Brompton Hospital, which is part of Guy's and St. Thomas's NHS Foundation Trust, and most of my imaging, clinical and academic work is done at King's College London in London. I just prepared a few slides in terms of my background. I finished medical school in Greece, but I had traveled a lot for kind of basic research in cardiology in the US for several months, and then clinical training in cardiology in Berlin, in Charité Campus Mitte. And then in terms of my postgraduate training in clinical cardiology, that was done primarily in London at Royal Brompton Hospital, and a rotation in other London hospitals like University College London, and then in the tertiary center in Athens, Onasio Cardiovascular Center. And I did my PhD in MRI in congenital heart disease. That was in King's College London. I finished it several months ago. And as I said, at the moment, I'm a consultant at Royal Brompton Hospital, and I continue my clinical and academic MRI interest at King's College London in the same institution. And so that's a very short summary of my clinical and academic background. Shall I stop sharing and proceed to the next speaker? Judith, I think you're muted.
Judith, you're muted. You need to unmute.
Yes, sorry. Thank you. Yeah, can you hear me now?
Yes.
Yeah, perfect. Thank you so much, Dr. Fotaki. I think we will get back to the details of your career journey in the next hour. Our next speaker is Dr. Gastao Cruz from the University of Michigan. So Dr. Cruz, please proceed with your presentation.
Thank you. Thanks for the invitation. Very briefly, I did my PhD in physics back in Portugal, and then I did a master's in medical physics in London before I also went to King's College London, a little bit before Anastasia joined us, actually. And there I did my PhD with Dr. Claudia Prieto and Bodnar, and we did a lot of work on motion correction. I know this is a cardiac focus group, but we also did a lot of abdominal work when we developed methods, that allow you to do free breathing scans, and we correct for all sorts of respiratory and cardiac motions happening in the abdomen or in the heart. In the heart, we did a lot of work in coronaries, a lot of cool work that actually Anastasia is also involved in. And after my PhD, I actually stuck around for several years at King's College, continuing to work with the same people during my postdoc. And at that time, we were taking a look more towards quantitative imaging using fingerprinting. And so we also developed a lot of methods to do fingerprinting in 3D and in different applications and mapping different parameters beyond just your standard T1 and T2. I stayed in London for about 10 years, more or less, for a long time. And recently I've come to University of Michigan initially as a research scientist. And we've done some work on extremely fast real-time imaging at low field. And also doing some work continuing along the same lines of fingerprinting, now with different applications like kidney. And more recently, I've started a position as an assistant professor here, and now we're more focused on abdominal fingerprinting to continue to do quantitative imaging and tissue characterization for these challenging organs. So today, I'm an assistant professor here at Michigan, the University of Michigan. With all these lovely people. We have a very big group working on all sorts of things, a lot of them cardiac, some of them don't. And we're also hiring, so PhDs and postdocs, so anyone interested, feel free to get in touch. And thanks.
Amazing. Thank you so much, Dr. Cruz. And finally, we have Dr. Ning Jin from Siemens Healthineers. Dr. Ryan, it's over to you.
Let me share my slides. Can you see my slides?
Not yet.
Okay. Let me just try again. Can you see my slides?
Yes, we can. Thank you.
Thank you so much for the invitation from SMRA Early Careers community. My name is Ning Jin. I'm a scientist working in Siemens Healthineers. Also, a very brief introduction for myself. For my bachelor, I did biomedical engineering in China, in Zhejiang University. After that, I moved to United States to start my PhD in biomedical engineering at Northwestern University in Chicago. After I finished my PhD, I joined Siemens as a scientist in mRNA. I first located in Columbus, then moved to Cleveland, Ohio. So through my years, I've been working different positions, but still in the mRNA department. And also I'm an adjunct assistant professor with the Ohio University. So for my PhD, my topic is a functional MR in the abdomen, including technical developments and preclinical investigations. It's not very cardiac focused, but it's also addresses some similar questions like the respiratory motion artifacts. For my technical developments, including free breathing acquisition for flow measurements and T2 star and T2 mapping using the self-gating technique. For self-gating technique, which is also commonly used in a lot of cardiac MR applications. And also I did improved diffusion imaging for the kidney. For preclinical investigations, it's a non-invasive liver fibrosis staging in a rat model using carbogen gas challenge both MR imaging. After my PhD, I joined the Siemens. For my responsibilities, there are several-fold. The first important part is prototype development. So for myself, mostly I focus on flow imaging, including 2D and 4D flow. but basically all aspects like acceleration techniques, improve quantification quality, image quality, and also recently mostly focus on inline quantification analysis to make 4D flow more accessible, and the results can be viewed directly on the scanner. Also, I'm exploring the cardiac MR on 0.5 IT free max scanners with collaborators. Also, the other important side of my work is the customer supports and collaborations. I'm working with many customers working on 2D and 4D flow, like the Northwestern University, Ohio State University, UCSF, and a lot more customers. I don't have space to list here. So that's all from my side.
Thank you. So thank you to all of our speakers for their wonderful presentations. So now we'll move on to the Q&A part of our session. If anybody in the audience has a question, feel free to drop it in the chat. But to start with, we'll go with some of our more just kind of sort of basic questions. So first off, and feel free to answer however any of you can answer however you feel. But how did you first get involved with MRI, and what sort of made you decide to study MRI in your postgraduate career?
I can start. Well, the honest answer to that is that I was always interested in imaging, but mostly in echo. And I always wanted to do something kind of more structured in terms of research. So I wanted to do a PhD. And when I was looking for a PhD in 2018 to 20, it took me 2 years to find a suitable one. There were no PhDs in echocardiography. and I thought René Botnar looked very kind. And I thought, okay, I might give MRI a try. In the beginning, I didn't enjoy it because I felt you're too distant to the patient. I thought echo is more like, direct. You practically hug them and you scan them. So I remember the first 6 months I didn't enjoy. But then it has such a vast science of like physics and engineering behind it, and for me that was extremely attractive and inspirational. And also my professors, Professor Claudia Prieto and René Botnar, are quite inspiring people and very nice to work with. So yeah, this is how it started, and I hope I do continue to work in that in the years to come.
Then for me, I came to US in 2006 to start my PhD. When I first enrolled at Northwestern University, I was enrolled to do optical imaging instead of MRI. So I know I did not like that. Because it was in a dark basement and basically have to adjust all the lenses and like the light path wave. I knew right away it was not the same for me. Then I was very interested in imaging because I feel it was really cool. There's some device, basically you can use that to look at the internal of your organs. Then I talked to different professors. At the time, I talked to my advisor, Dr. Andy Larson. He took me to the basement in Olsen Pavilion at Northwestern University, and he showed me the machine and he showed me like what we can do, how to operate the machine. I felt like in love right away. So I feel it was such a cool machine, and I can operate the machine myself and imaging volunteers and patients. So then I started to decide to work on MRI.
Yeah, and I studied physics, and I've always wanted to do something applied with it, possibly medical. And when I did my master's in medical physics, you get exposed to all sorts of modalities, and just MRI was just the coolest and most interesting one, from the engineering and the physics and the kind of flexibility that you can do with it. There's a lot of, I feel, uncharted ground with MR, maybe more so than with some of the other modalities. And so that uncharted ground gives really spikes your curiosity about what kind of stuff you can do with it. So you just have to go and sneak a peek and play with it. And then once you start experimenting, then yeah, you're hooked.
Okay.
Great.
So thank you for your
Thank
answers.
you. Thank you all. Can you hear me now? Sorry.
Yeah, we can hear you.
Okay, perfect. So thank you so much for your answers. Now let's talk about some key milestones in your careers. Let's start with Dr. Fotaki. What were the biggest milestones in your career?
Yeah, thank you for the question. So, I think the biggest milestone was like quitting the PhD that I had started. So it's a quitting the milestone, quitting the PhD that I had started in back home in Greece, and coming to London for kind of advanced clinical training in pediatric cardiology, and then pursuing the PhD at King's. So I would say that quitting something that didn't feel very right at that point was the biggest milestone, and taking the big leap and relocating to London. It's just that sometimes we have to quit things that don't feel right because there might be better things ahead.
Yeah, I see. And Dr. Cruz, what were the highlights for you in your career?
Maybe on a CV would be becoming a junior fellow at the SMRA. But honestly, the biggest personal milestone is getting the first paper published. It's always so publishing papers is hard. The reviewing process is hard, and the first time you go through it, it can be a bit disheartening. And we're always very sensitive of our own work, so getting it critiqued is not an easy experience at first. Um, so going through that process of persevering through multiple rounds, and I think the first paper had like 3.5 reviewing rounds. It was a long one. So that one was it was a doozy, but we powered through. So that I think that's a good learning experience to just persevere through uh, whatever gets thrown at you, you know.
Yes, I agree. It's definitely a milestone for every early career researcher. And Dr. Irin, one moment you stand out in your career?
So for me, I think as a scientist in Siemens, we develop the WIP sequences and distribute that to customers. And we see the interesting and very nice results coming back from customers. That's really rewarding and very encouraging for our work. So for me, I think the compressed sensing 40 flow WIP sequence was developed by myself and has been distributed around the world and used by many customers. And I see the nice results and very encouraging results from all the customers. Share all the interesting and nice cases to me. That's like the most rewarding process.
Okay. So the next question we have, did you ever experience any pushback because of your gender or ethnicity throughout your career? I'm just curious about any experiences or thoughts you might have on that. We'll go in the same order. So Dr. Fotaki, do you have any thoughts?
No, me personally, no, I have not experienced anything different because of ethnicity or gender. It was very hard to relocate several times, like from Berlin back to Greece, and from Greece back to London, and adjusting to the new system. But once I was part of the system, there was never any issue. I think UK is quite good with that, to be honest.
I've also gone through the same UK experience, so I can't say I've ever experienced anything along those lines, no.
For me, probably not the problem, gender or ethnicity. For me, it's more the language problem. I came from China, so in China we learn English, but mostly like written English, not speaking English. So when I first came to US and I started my PhD program, there was quite an uphill for me to try to understand what the professor says in the class and try to take notes and to follow the lessons and also communicate with my fellow students. That was obstacle for me.
That's great to hear. It's nice to hear that I have had to face that many problems like that. So I think we'll start moving towards like career development questions.
Yes, and yes, and Dr. Fotaki, is there anything that you would have done differently in your career?
I think my answer would be very similar to Gastao's answer about the papers. I have experienced quite several rejections, not just from papers, like from job interviews, several rejections from grants, and I took everything, and I still try, like I'm still taking everything a lot too hard. It's hard not to take it personal or as a judgment to your work. And it's also hard not to compare yourself with people that actually like published earlier or managed to get the grant. And but then once my professor told me this advice: for any grant you get, you have probably submitted another 5, and you had 5 rejections from every paper you published. You have a couple of rejections or reviews. So going back, I would have saved myself, I think, a little bit of sadness and of disappointment and self-doubt across these lines. So I would try not to take things so personal, get so sad. It's always nice to have some feedback, and this can also make you stronger as a candidate, make the paper stronger. So yeah, I wouldn't get so sad about rejections. Nothing is personal.
Yeah, I think this publish or perish tendency puts a lot of pressure on every scientist. So I agree. And Dr. Cruz, what about you? Any reflections on what you might have changed?
I think early in your career, especially if you want to do academia, it's very important to publish a lot. It is very much publish or perish, and you try to publish as much as you can. Something that I do recommend you try to do early if you want to do academia, and something the US does quite well, is to try your hand at grant writing, smaller grants, get that experience. Expect a rejection. That's what's going to happen, especially in the beginning, more so than ever. But getting that early experience of writing grants is something that I would have started writing them a little bit earlier. Even, towards the end of my PhD, there's already, some mechanisms for finishing PhD students to start writing some grants and getting that exposure. So that's something I would recommend. Yeah.
Yes, I can see that it's good if you can look into the funding mechanisms that are available for early career scientists. And Dr. Cruz, what are your thoughts? What you would have done differently in your career? Sorry, Dr. Rin.
So for me, I think I will try to communicate with people during my PhD more, like talk to like the other professors, talk to senior students, to learn from them, and also talk to. For me, I'm Northwestern, so it's a very unique environment. We have a very close collaboration between the Siemens and Northwestern. So actually, there was a Siemens office there, so it's quite different and quite good actually for students. For me, I would like to. I will ask myself to talk to the other Siemens people there earlier to establish the connection and also to learn from them, to get some experience from them, to see what we needed to prepare myself more ready for industry work.
Okay. We have some questions in the chat, it looks like. Do you have any specific advice you have for students in terms of approaches to take for success? What do you think in terms of like specific approaches or personal qualities helped you to become successful?
Okay, I can start. I think the most important thing in research is perseverance. Be ready to fail 100 times. Uh, and this is true for experiments you're doing, for papers you're submitting, for grants, whatever you do. You're probably only going to succeed at the 101st time you try. And the only way to get there is to first fail the first 100 times. So you're going to hit a lot of brick walls. You're going to get down, but you have to keep getting back up at the end. So perseverance, I feel, is very important in this area.
I echo that. That's very important for me also. I have a similar experience in terms of papers or like WIP developments or prototype developments. It will never work the first try, and needs many times of like for paper needs a revisement and go through the review process, address all the questions. For sequence developments or for reconstruction developments, there are many bugs you need to fix and figure out all the artifacts and what is going on. So I feel like the failure is okay, but just how to face with the failures, how to fight it, how to figure out the right direction to go and be successful. So don't be afraid if one time doesn't work, just to be strong. That's one thing. And the other thing is for me, coming from the like academia environment to the industry environment actually is kind of different. From as a PhD student, actually daily life is kind of simple. Just need to work on my own project and talk to my advisor, make sure my project is on track. But when I moved to the industry position, I was put into a new environment as a science scientist at the Ohio State University. When I first started, it was I have to say it was a kind of difficult because it was a completely new environment. From customer side, they expect me to come in as someone very experienced Siemens scientist who should know everything. But in reality, I'm just a PhD student coming out of school. So I have to learn how to work in the environment, work with different people, work with the other researchers, work with clinicians, and work with technologists. That's a very important skills to learn, and how to communicate with people.
Yeah, for me, I think one piece of advice is to choose your clinical teams and your professors in academia wisely. Those are the people you're going to spend at least 8 hours of your day, probably 12. Those are the people that they are going to like inspire and motivate you. These are the people that you're going to work with their work ethic. So it's a very important decision, and early in our career, we feel challenged that they interview us. Those are the senior people. But I think for me, the paradigm should change. It's also like the younger people, the younger researchers that interview their professors, because they should have a say to what kind of people they want to work with, to what kind of people or teams or labs they are going to, they want to devote their effort, their time, their sweat, their intelligence. So I would motivate everybody to be very wise and meticulous and look at subtle qualities, because this is going to be our everyday life, and we are also going to be taught skills by those people. So we have to be quite careful.
Okay. We have another question in the chat too. How do like I guess your family duties, how does that align with your scientific career, do you feel struggle to kind of balance the two, or?
So for me, I have two daughters. One is 8 and the other is 11. So can see like families and their life, how to balance the two. I feel like it's important. So when I'm working, I try to focus, try to do my work. But after job, my two daughters, they are demanding, and I have to spend the quality time with them to take them to different activities to fulfill mom responsibility. That's also time consuming.
I don't have kids at the moment, so it's a little bit easier. But it, it, this job can be on one hand you work a lot, but on the other hand, in some areas you have some flexibility. So that's also an advantage that you generally have in research, where you can maybe uh, play with that a little bit. But I imagine it's not easy. Yeah.
I also don't have any kids at the moment. I would love to. um, I don't see any contradiction to that. Same way as I don't see any contradiction to academia and clinical. It's just different sources of motivation, and as you do both with commitment and love, and I imagine kind of a schedule around it. I think everything is feasible. We have so many examples of very, very, very successful academic and clinical scientists with families.
Thank you so much for your answers. And we have another question in the chat. At various stages in your career, how did you vet the mentors that you ended up choosing? Let's start with Dr. Yin now.
So for me, actually, for my PhD mentor, I think at the time I was looking for an MRI imaging type of a position, and he was open, and he just I just talked to him, and he offered me the position. So I feel like different mentors may have a different type of a style. So for my mentor, he is not managing, so he gave me a lot of flexibility to explore the direction I wanted to work on for my PhD. So for me, I know I wanted to work in industry after graduation, so I would like to work on more technical development projects. Basically, he pointed me the direction. Maybe we can work out some free breathing technique to improve the quality of flow imaging or the others. And so then I can basically I study the topic and figure out what will be the approaches we need to develop and how to develop that. So I like this kind of a style instead of micromanaging. So he just gave me flexibility to explore things I would like to work on myself. For my industry position, then that's my manager. I don't think it's someone I can choose to be my manager. But I like to work with my managers. They also give me the flexibilities. So for the Siemens position, it's quite unique. Basically, I feel like it's a merge between the academia position and industry position. So I can still work on research and work on the prototype developments and work on manuscripts and papers, etc. And also, on the other hand, work with the customers closely on various interesting, exciting research projects.
Interesting. And Dr. Cruz, what was your experience?
For my PhD, I actually I got lucky. I just looked at a cool project, and I got lucky because I got to work with wonderful people in King's, and I mean I stayed there for between my PhD and several postdocs for over 10 years. So clearly we all got along. Then afterwards, when I moved to Michigan, I did talk to, you know, a lot of people when deciding to do the next move. And when I met Nicole Cyberlick and Vikas Kulani, they were just we just saw eye to eye in a lot of goals that we have for research, for life, which is, there was just an understanding. So I think uh, finding a good fit is very important for sure. And Anastasia already alluded to this. Finding someone that has a similar view outlook as what you're that's very important. And in my PhD, I just got lucky. And maybe Anastasia can talk a little bit more because I think she, like she was saying before, she almost got into MR because she liked the person that she was potentially working with. So maybe she's got something more relevant to say.
Um, yeah, so as far as me is concerned, so for my first clinical mentor, who is we're still in touch, we work in the same institution. The thing that played a very important role at that point, I was only 24, was that in her, you know, introductory page, instead of mentioning her papers, she said that she came from abroad and she was very keen to train students from like doctors from other countries, which at that point I found very comforting because it was a very, very big step for me to relocate for the third time in 2 years. And actually that was my only criteria. In the long term, it turned out that this woman was wonderful in terms of kindness and scientific background. Amazing patient contact. So I learned a lot from all perspectives. For the PhD, and I still collaborate with these people from King's that have now relocated in Chile, but in terms of academia, I think kindness would be the first thing. Professor Bodnar and Professor Prieto were very welcoming in the first place, very honest about, like when we first met 1 year before I started, they were very honest about not having a grant, but that would be an option. But like they committed to finding time to have an in-person meeting. So that to me was very professional. And then at that point, because I was more mature from a scientific point of view, I liked a lot the fact that they worked without contrast agents. And my background is pediatric and fetal cardiology, so the less contrast, the better. So at that point, I also had some kind of scientific, let's say, background to or demands from my professors. But I would say that the first thing was their kindness and their commitment to work and the whole professionalism that they treated me despite having zero MRI background. Yeah, so personality is important.
Okay. So next question. What would you say are the most important skill sets for your position? You know, the major like skills or things that have helped you along the way. Maybe Dr. Cruz, we can start with you.
Did you say me? Sorry.
Sorry, yeah, Dr. Cruz.
Oh,
We can start with you,
sorry.
yeah.
I cut out a little bit. At an assistant professor position, it's grant writing and managing projects. Early in your career, like I said, you want to publish a lot of papers. That is the lifeblood of your CV, and that's what's going to distinguish you from other candidates for other positions that you are applying to. Once you get into the next step, then instead of paper, it's going to be grants. So you need to be really good at grant writing, which is a whole nother skill set, and a challenging one at that. So yeah, that's number one. And number two is I would say in terms of managing people, finding maybe the right project for the right person, trying to do a little bit of fitting. If you can, different people have different interests, right? So if you can find what makes them tick, then you can find something that makes them happy, and then they'll do some cool research with the parameters that they're given. So without micromanaging, trying to find a good fit for a good research candidate in a project. Yeah.
Maybe Dr. Jin.
So I would say there are several things. The first is the technical skills, like the MR physics, power sequence development, like how to do the programming, how to do like the programming in different type of languages in C++, Python, MATLAB, etc. Those are very important skills to fulfill the technical perspective of this position in R&D. The other is communication skills, how to work with different people, how to talk to people, like talk to clinicians, how to work with the other researchers at different research institutions, and also how to work with contract admins in our own institution and other institutions, and also how to communicate with texts. Those are very important. So they have to like be able to communicate with everyone effectively. And the other thing is time management. There are a lot of projects internally and externally with the customers have to be able to just manage my time effectively, work on different projects, also balance the time between family and job. So I think the three perspectives are very important.
Related to the previous question, but to get to the position you are at, what would you focus on learning in the university? Like what major or would you like to choose? Can we start with Dr. Fotaki?
So my background, as I said, is clinical. So I don't know. Medical school is too generic. You have to learn lots and lots of things, from like basic sciences to clinical skills, and in our case, a little bit of physics. I had just like 2 semesters of physics. That is now pretty much what I'm doing half my time. So I'm not sure that I would focus so much on medical school in terms of undergraduate. I think medical school is a time to find yourself, find what inspires you, what you want to do. In all sorts, from a technical standpoint, from a clinical standpoint, who are the people that you want to work with, at which environment do you want, like an academic or working in a high-level tertiary center, and then I think it's probably the time of the PhD where you should focus more on the skills that you're going to develop, because that is what probably you're going to work on your postdoc. And along the lines, I agree with what Dr. Yin and Gastao already mentioned. You have to solidify your skills in our case, in imaging, physics, engineering, or also clinical interpretation. You have to be solid there, because then you have more time to devote to academia. And the second thing is you have to learn how to collaborate. It's not always easy. For clinicians, it's also like a lot of work with radiographers, with other clinicians, with industry. So that is an important skill that you need to learn during your PhD, I believe.
And Dr. Cruz, what are your thoughts?
In terms of specific subjects that I think are very important from the background of engineering, I think you should aim to really master linear algebra, calculus, and a little bit of statistics. And if you have those like really, really solid, then you can tackle anything else. You can learn a little bit of programming and they'll do post programming. You have the math background, you can learn the MR physics. It's not that complicated. You can do deep learning because you have all the linear algebra and statistics background. So from the engineering side, there's these three core mathematics subjects that are really important, and they've been really important for the last 20 years, I'd say. So specifically those, I would say, maybe for the engineering.
Thank you. And Dr. Rien?
I agree with Dr. Cruz.
Do you think
the subjects are, the maths are very, very important. That's basics, and also all the technical skills are important. And also, I would say to know what you want to do after graduation, which direction you want to go. If you want to go to academia, then probably focus more on grant writing skills and do that as soon as possible. Maybe you can apply for small grants as a practice to see how the process is like. And if you want to go to industry, for example, if you want to work for Siemens, you can talk to the Siemens scientists and to see what our life is, what's our job responsibilities, to see whether that's a good fit for you. To define that at the early stage and work toward the direction.
Thank you.
Okay. So now we'll move on to sort of our last set of questions on like overall outlook of the field. So how do you each think that academia and industry and like the clinic can all work together better? Like, do you see ways for easier collaboration between these sort of three areas, or what are your thoughts? Maybe you can start with Dr. Jin.
Yeah, so actually for my position, it's quite unique. It's a combination between academia, industry position. So I work with people in academia, in clinical settings and industry. I think from the academia standpoint, when I was a PhD student, I feel one thing that is missing is to implement the technique and use the technique clinically. For my PhD projects, a lot of the projects I was just done that in a way and call the raw data and reconstructed in offline using MATLAB. And after the paper is published, then the technique itself is put on a shelf. I feel like it's quite a lost without actually to have the technique used by the clinicians and really benefit the society. So I think if we can implement the techniques and be easily used by clinical fellows in the clinical environments, that's very important. Like recently in Siemens, we have 5 frameworks or open recon frameworks that will enable the researchers to implement the reconstruction or post-processing easier. So that can be used by the clinical environment instead of like for the clinicians to gather raw data and put it on the machine to reconstruct in views images. And that's very time consuming. And also from like the industry standpoint, we work with clinicians. I think we need to talk to the clinicians and try to understand what's the clinical problems or what's the clinical need, and to see maybe we can develop a kind of a technique or contrast that can benefit the patient diagnosis. And also, I think talking to the technologist is very, very helpful, like to understand their clinical workflow, how they did their work, what's their process, what's a bottleneck to slow down their workflow, so we can address those pain points. That would be very benefit. And they're also working closely with our academia partners to work with our academia partners together. We can translate the techniques into a fashion that can be used by the clinical environment. So by combining the three aspects together, I think that could really benefit the patients.
And Dr. Fotaki, your thoughts?
Yeah, thank you. I don't have much to add to Dr. Yin's sorry for the pronunciation. Answer. I think it's very important to work closely together. We have in-house at King's people from Siemens Healthineers who and that is very, very helpful because we have regular meetings, we talk to them about things we would like to achieve, and then they suggest solutions. One thing that it's probably a thought for the future is whether we can try and facilitate more international forums, because there are many WIPs in other institutions that clinicians, particularly in smaller institutions, in kind of less developed countries or not in academic centers, they're not aware of. So I'm not sure how we could establish these forums outside, for example, the big MRI meetings, ISMRM, SMRA, or SMR. That would be something I think very useful, particularly for smaller centers.
And Dr. Cruz?
I think, right, for good collaborations, I think it's important to understand what the other parties are looking to get out of it. Between the clinical environment, the academic, and the industry, they all have different goals, right? The clinical people, they want to bring good um, treatment to their patients and good experiences to the patients, and that's a focus. The academic people, they just want to publish papers, and the industry is looking into bringing more value to their customers via novel products and services and whatnot. So if you can clearly communicate and understand what are the goals that each party has, then you can find the common grounds to build good collaboration so that everybody gets what they want. Because obviously everybody's has different goals here in a way, although we're collaborating towards the same big goal.
Okay, we have one more question in the chat, and this will probably be our last one, I think, before we need to wrap it up. So a large part of career transition is learning management. Is there any resources you found helpful in learning how to manage teams?
I'm just going to jump in and say that I'm just starting this now, and I don't have any. If you got any good resources for me, please let me know. That's a great question. I'm still learning that.
Maybe Dr. Fotaki, do you have any thoughts or?
Sorry, is it about time management or people or teams management? I missed that.
I think either way, really. I think the question is more focused on people managing, but time management is also a really great skill to have, so.
No, I don't have any resources on that. I don't know. I think in some of these things it's just experience and talking to people that you find successful about how they did things. That is my way to go, because I find that sometimes, like, I have done things about teams management, like from King's courses, but you don't know who is the person who giving you this advice. It's probably some guru somewhere that you don't know how they work. What I personally do is find someone that I like how he or she works and the way they work, and when I have a challenge, go to them with my problem and ask them how would they manage it in terms of managing other colleagues or the team of students or the team of new clinical fellows. So I would suggest just communicate with senior people that you like their work and ask them questions with your particular challenges. That would be my advice. Talk to people that you admire.
And Dr. Jin?
Me neither. I don't have any good advice. I think talk to the people and learn from the others. And also, I would like to learn the time management skills and management, like people skills better. If you have any resources, please feel free to share with us.
Thank you so much. And just one very quick last question. What is the one thing you want the audience to take away from your experience, just in one sentence for each of you? Dr. Fotaki?
It has to be for me, choose your teachers wisely.
Thank you. Dr. Cruz, what is your
For me,
take-home
I would
message?
say perseverance, especially during your PhD. It's hard. You're learning a lot of stuff, and all of a sudden you're competing in a way scientifically with people all over the world that have been doing this for 10 years. Don't be afraid of failing. That's just a necessary step towards success. So persevere, try again, try again, try again.
Thank you. And Dr. Yin?
I think it's talk to your fellows, your advisors, and the other colleagues, and learn from them.
Thank you so much. And I think we would close this session. I think for me, it was extremely inspiring and insightful. So thank you so much for you all being here. And thank you for the audience for the engaging questions. Is there anything you would like to ask? I haven't seen any questions in the chat. So thank you so much for the speakers for sharing their valuable insights. And we appreciate your time and contribution to our webinar. And have a great day, everyone. And we look forward to seeing you at our next event. Thank you.
Thank you.
Thank you very much for organizing. Bye. Bye.
Thank you. Bye.
Thank you. Goodbye.